Hi everyone, here are your notes for section 2.5, part 1. Today we're going to start introducing how we use proofs in our logical reasoning. And the easiest way to do that is to just do something that we already know how to do, which is solve equations. So today we're going to be focusing on algebraic proofs. Okay, so we've got some key concepts here that we need to work through. We kind of introduced these in the beginning of the year when we were solving equations, and these are going to be reasons that we use for justification of why we do something that we do. Okay, so the first one we have here is the addition property of equality. And what the addition property of equality says is if we have something such as A is equal to B, so 3 is equal to 3 or 4 is equal to 4, then it must be true that I can add some number C to both sides and it will still stay a true statement. So for example, don't put this in your notes, just watch. If I had 3 is equal to 3, that's true. If I do 3 plus 1 on both sides, will that always stay true? Yeah, because 4 would equal 4. Okay, so addition property of equality. As long as you add the same number to both sides of your equal sign, then your equation will stay equal. It'll stay balanced. Your subtraction property of equality is very similar. So if A is equal to B, then we can subtract some number C. So A minus C is equal to B minus C, and it would still stay true. So again, for example, you don't have to put this in your notes. If we started with our 3 equals 3, and we did 3 minus 1, well, that's 2. 3 minus 1 is also 2. So the left still stays equal to the right as long as I make it equal, balance. What I do to one side, I must do to the other side. Multiplication property of equality. So if we have our A is equal to B again, then I can take some number C and multiply it by A and B, and it will still stay equal. Right, so if we go back to our 3 equals 3, if I do 3 times 2, that's going to be the same as 3 times 2. Okay, so multiplication, multiplying something on both sides will keep your equation equal. Division, if A is equal to B, then we can divide both sides by some number C, and it will still stay balanced, it'll still stay equal. Okay, so addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. If you want to use the letters just P-O-E instead of writing out property of equality, you are more than welcome to do that if you want to be lazy, but it is important that you do actually put the P-O-E there because that's the name of the property. Okay. All right, so these are easy to come by because if you're solving an equation and you add something to both sides, you know it's going to be the addition property of equality. Or if you subtract something from both sides, then you know it's going to be the subtraction property of equality. When we get into other properties where it might not be as simple to find, they might be a little bit harder to remember. So let's work through these. Here we have the substitution property of equality. And what the substitution property of equality says is, if we go back to that A is equal to B, then A, I want to write this down correctly, A can be substituted. Okay, so substitute it, someone teaches, someone substitutes something in place of something, for B in any equation or expression. Probably do not have enough space in your box there, so I apologize. Squeeze it in as best as you can. Okay, so that's our substitution property of equality. Distributive property, you guys are used to distributive property, hopefully. So distributive property is A times the quantity B plus C is equal to AB plus AC. And some other ones that might be new to you guys are what's called the transitive property of equality and our symmetric property of equality. So transitive says for any real numbers, A, comma, B, comma, C, if A is equal to B and B is equal to C, then if we think about our law of syllogism, I can take out that link of B and I'm left with the A is equal to C. Okay, so we got transitive property, so you can take out that middle link. That's kind of like your law of syllogism. And then our symmetric property says for any real numbers of A and B, if A is equal to B, then I can switch the order and make B equal to A. Okay, so the only time we're going to be really using the symmetric property is when we had something like 3 is equal to x, and we're used to writing the x first. So I would use the symmetric property to flip the order. Okay, that's your symmetric property. Okay, so now let's put this all into action. Oops, missed some yet. Reflexive property. Reflexive property just tells us that if we have some number A, well no, so it's not even if, A is equal to itself. That's all your reflexive property is. So reflexive property, think about your reflection. You look at yourself in the mirror, so you see yourself. Your symmetric property, it would be you flipping. So if you were sitting next to your partner and you guys would just switch spots, that would be the symmetric property. And then the transitive property is you transfer from one to the next, to the next, to the next, to the next, and get to the last. Okay. And then whenever we do something in our solving, like combining like terms, or evaluating something, we would just write simplify. Okay. All right, so when we solve our algebraic equations, we're going to do all of our work on one side of what we call a T-chart, a two-column proof. And then we're going to do all of our reasons or our justifications on the other side. So we're going to kind of be explaining our steps, okay? So here's the first one set up for you. I don't know if you want to, oh, you already have this in front of you. I was going to say pause this and get this written down, but you have this in your notes. So we have an equation that we need to solve, and then we need to justify all of the steps. So the equation is 3x plus 8 is equal to negative 4x minus 34. And it's solved already for us. So that was nice. So they did half the battle. Now we need to provide the reasons. So notice that in that first line, 3x plus 8 equals negative 4x minus 34. That's the original equation. So we always start our first line with a given because that's what's given to us. So we're going to write our word given there. Now, what's a little bit complicated here is I put everything horizontally instead of vertically. Normally I'm a vertical solving of equations, but here it was vertically. So let's see what happened. So it looks like they found their smallest, or they, I say they, I mean me. I found my smallest x term, which is a negative 4x. If I wanted to move it, what would we do? Well, we would add 4x to both sides. So notice in line 2, I have a plus 4x happening on both sides. Well, which property lets me add something to both sides and still keep it equal? That would be the addition property of equality. Then what happened from line 3 to line 4? Well, I see a 7x. Where'd that 7x come from? Well, that 7x came from adding my 3x plus my 4x. So we combine like terms. So over here, I'm just going to write a simplify. So what did we do? We simplified the left side and the right side of the equation. Then what would happen next? What would be the next thing you would do? You would subtract 8 from both sides. So notice here, we subtracted 8 from both sides. So that would be a subtraction property of equality. And please don't abbreviate subtraction to just sub, because then I won't know if you mean substitution or if you mean subtraction. So write it out. Don't be lazy. Then what happened? They put the negative 34 and the negative 8 together to make negative 42. So that was a simplifying, a combining of like terms, or just evaluating. And then the last step would be a division. So what did we do to get there? We divide it. Division property of equality. Okay, and we don't need a symmetric property because the x is already on the left. All right, so can we do one on our own? Well, not on our own, but solve it and justify. So let's go ahead and create a t-chart just to kind of get ourselves organized here. Okay, and then on the left side, we're going to put our equations. So and I label my lines just to make it easier when we're talking. So 60 is equal to negative 3 times 8x minus 4, which is the given equation. Okay, so over here is where we're going to put all of our reasons. So all those things that we just put in our notes, all of them are reasons, are things that we would list on the right-hand side of our t-chart. Okay, over here, number 2, and these are all statements on this side. All right, so line 2, what will we do first? Well, I would probably use the distributive property to get rid of that negative 3, or you could divide by negative 3 right away. It doesn't matter which one you want to do. My gut would take me to a distributive property right away. So negative 24x plus 12. What did we do? We did the distributive property. Distributive prop. I feel like there's a lot of extra letters there. Hopefully I spelled that. Yeah, I have an extra S. Where'd that come from? Distributive. There we go. All right, and then what's our next move? Our next move would be to subtract, and you can, if it's helpful for you to do a little kind of one of these guys, you can do that. I kind of skip some steps with my simplifying and just kind of go right from distributive to subtraction and do the simplifying kind of in between. That's fine if you don't want to show all of the steps. All right, so we got 60 minus 12 is what? 5, take away 8, so 48 is equal to negative 24x. So what did we do there? We subtract it, so the subtraction property of equality. And then our last move is to divide by negative 24. And again, you don't need to show that dividing by negative 24. You can just go right to the steps if you want. So that's going to be what? Negative 2 is equal to x, which is a division property of equality. And then we always should write that x on the left-hand side, so I'm going to flip it, which is the symmetric property allows us to flip it. Property of equality. Okay, so we solved the equation, we justified our steps. You could have solved it a different way, so hopefully you can get yourself to negative 2 and you're able to justify the steps that you chose. Okay, let's do another one. So make our t-chart. We're going to do our statements on the left, reasons on the right. Start line 1 with our equation, so 4x plus 5x equals 6 times x minus 8, given. All right, so what would you do first? Would you do the distributive property first, or would you combine like terms? Doesn't matter which one you do first. I'm going to do a simplify first. I'm going to turn that into a 9x is equal to, don't do 2 steps in the same line. Don't distribute and simplify. We need to write everything out. So what did I do? I did a simplify. My goodness, I can't simplify. Now let's go ahead and distribute. So 9x is equal to 6x minus 48. Distributive property. Prop. Okay. Now where would we go? Would you subtract the 6x over? Hopefully that's what you would do. So I'm going to do it without showing it. So I'm just going to go right to the simplified version. So 9x minus 6x would get you to the negative, or get you to 3x. So 3x is equal to negative 48. So we did a subtraction property of equality. And then we're going to divide by 3, which would get us, what, negative 16? Division. Property of equality. Did I do that math right? 3 goes into 4, 1, 18, yeah. Good. Okay. Done and done. So algebraic proofs. Next class, we're going to move into geometric proofs. So we're going to move away from algebraic and we're going to start adding in some geometry problems from chapter 1, and then which then also then incorporate algebra to them. So if you guys kind of remember what we did in chapter 1 with angle addition, segment addition, bisecting, and all of that good stuff, we'll bring that into play next class. Okay, so please move on to your next assignment. Bye.